welcome to another overdubbed video. Once again, the mixer hasn't recorded the sound, yet I didn't press any buttons wrong. I ought to go back to the old mixer from 1990 something and go back to the 640 picture quality. Anyway, we've got a Fidelity 1000. I like them, nobody else does. These are the bleed over boxes which everybody talks about, and this particular one is in its own box. This is the same customer. This is our box number 18, and it's the next to the last set, the penultimate of this customer's radio service jobs. So although it's a used set, it has come complete. We've got the original mic in a similar style to the ones I often use. Could do with a bit of silicone polish on it. It's all kind of gone rough. And it smells of being stored damp. We've got a guarantee. No, sorry, I'll start it that again. We've got this form here. If you pay them 10% of what you paid for the radio, which is for $69.99, then they will insure it for you against theft. Imagine that, somebody nicking your Fidelity 1000. It's got the original instruction book. And it's got the guarantee. You can see on there they do the record players things. They've quickly overprinted. We do CB radios as well. Usual instructions, no circuit diagram. But we all know it uses the great GT8 4.8 chassis, which of course is a variation of the GT8 5.8 or the 868. On this version you get an extension speaker socket at the back, which you don't actually get usually. It's had this extra one labelled 14, which is this strange little toggle switch which says on the back bleep. But actually when we get into this, it isn't a bleep at all. Got the original bracket, ninth lengths of power lead, banana plugs, perhaps I've used it as a base station. So if you cast your mind back to us doing the Rotel RVC 240 a few sets back from this same batch of radios that had the similar letters pinched off a video VHS cassette label, and you may remember that the set had got an illegal modification to make it shift in between channels. Well, that's what that switch turns out to be, and it says bleep on the back. I think that's just to put Busby off if they were ever expected. Expected. You don't expect the Spanish Inquisition. So we'll open this up. That's kind of a spoiler, isn't it? So that's what it is. It shifts it between channels illegally. Later on we found another modification that doesn't actually help as well. Right, so let's get it connected up. 13.8 volts. So we'll connect it up to the test instruments, and we'll connect it up to the instrument speaker connector there. So the Grade 858 chassis, which doesn't have the extension speakers socket, is quite a pain because it means we've got to go inside and clip onto the actual loudspeaker, which is so frustrating. And with these, the audio output on these is only 1.5 watts, so you really could do with an extension speaker anyway. So I say this the Fidelity 1000 at least has that, whereas the other GT858s don't. So it powers up. Right, we'll see what kind of power output it's doing. Now, the service manual says anything over 1.7 watts is acceptable. I think this is 2.5. Let's see what I write down. Oh no, it's 1.5, so it isn't acceptable as it is. You won't see one of these doing 4 watts. It's a 3.5 watt radio in reality. And it really doesn't matter. Most of the new sets you buy today are anything over 2.7 to 3.6. That one in our test car, Midland 78 Plus Multi, I don't think it does above 3.8 watts. Even, we've tweaked it to what we can. It's the way sets seem to have gone. Low power is 260 milliwatts. It's not adjustable on these sets. However, it's only drawing 584 milliamps. Now here was the shock, deviation. Just look at this. (15 kilohertz). Let's talk on several channels at once. Frequency just a little bit high, that's absolutely fine. 2779137 should of course be 2779125, but we do adjust it in the video, but it really didn't need it. And the meter was reading somewhere around 4, which the set wasn't doing 4, of course, but that's how you're supposed to set them, whether they're doing 4 or whatever. The switches work. There's only one switch on it, and that's high-low power at the back. No PA. Speaker works, mic works. So we'll set the signal generator to 2779.125-ish, 9-ish, something around there. So we don't need to quite match it exactly to what it's working on. And by the time I move on to the receiver of this, I'll already have put the set on frequency. So let's look at the cyanide reading. We'll start with the 12. And it's not insensitive at all, but you'll see in the video I do get quite an improvement. Is that 0.5 microvolts? I think it says that, 0.51, something like that. 0.48, 42. I'm looking at this on a 6-inch monitor. And 1.4 microvolts for 20 dB cyanide. So yeah, there's nothing wrong with those receive figures. You'll see the squelch isn't perfect, and that does get rectified when I retune the receiver. So it's 160 microvolts for the full squelch, which is a bit too tight for my liking, but there's no hard and fast rule on this. At least it opens. And then maximum sensitivity, the threshold is 1.9 microvolts, which isn't that good. It'd be a bit choppy around scratchy corner, but not as bad as that Team 8000, which was about 8 microvolts when we tested it. And looking at the meter, not that far out. 60 microvolts was S9, and you'll see later on in the video we don't quite get it to 100 microvolts. The set won't do that. So it's time to take the lids off. We need to unsolder the speaker, and straight away we can see the same brown masking tape that we'd got in the Rotel 240 with all those nasty modifications. So we then see that the little toggle switch on the back has 2 black wires. And of course it isn't a Roger bleep at all. It changes the way the phase lock loop chip is programmed. It's solid wire rather than multi-strand wire, and that's not ideal because it's a bit rigid. So when you're soldering it to printed circuit boards, it's very easy for the tracks to get ripped off. Now that hasn't happened in this case. I'm just pointing out that it can easily happen. So let's have a look at what it's actually doing. Do I go over to the frequency counter, or do I just discuss it? But it goes kind of in between channel. So we've now got 2747, well, of frequency. So it's lower than channel 1. Exactly like that Rotel 240 did. So the next bit of fun is trying to unsolder the VCO can. Because the more you heat it up, the more the solder actually flows as capillary action. It makes it harder and harder. I think eventually we'd do this off camera. I suck some of the solder out. Then you bend the lugs. And then you should be able to just lift up the VCO cover. The reason you put solder on that is so the thing doesn't become microphonic. As you can see, I've given up doing that. We'll do that off camera later. Microphone is kind of while it makes the thing rattle on in its VCO. He loved his masking tape, didn't he, this guy? Unfortunately, he's cut one of the tracks there, so we have to put a little link in. So we find a bit of multi-strand wire kicking around on the bench, probably out of the last naughty modification, and cut a bit of that off and put back the missing bit of track. There we go, that's your little bit of yellow link put in. And that's all we had to do to get rid of that illegal modification. And there we are on the frequency counter where it should be. Now it's slightly different off frequency, so we do have to realign that. So cut those black wires off and discard them. It's a bit sad, isn't it, when the golden plated screwdriver expert even has to modify Fidelity 1000. And we'll see another modification later on in the video. Eagle-eyed viewers will spot it right now. We're going to have to kind of force this cover apart whilst we'll just tin it. I haven't got any flux on this bench. And kind of force it apart. And then we can suck the solder off later. Eureka, we've actually just about parted it there. There we go. All we want to do is adjust the frequency. So we're not going to do the VCO on this. There's no reason to have to touch that, and I have shown how that's done on other Fidelity 1000 videos in the back catalogue. It is a bit of a faff, and it doesn't drift. Look at what we find. We find a crystal filter on receive. So that's something else that's going to have to come out and be reversed. Right, so it's time to dig this service manual out. I do have an original copy somewhere, so we have to, at the moment, have to use this photocopy. One day I'll dig out the real one. So that's the frequency adjust, trimming the reference crystal there to bring the radio on frequency. So just slightly high. They do drop naturally with age, so it's unusual to find a radio that's 40 years old to be high. They usually are low. So clearly it's been fiddled with at some point. Well, we know it has, don't we? Usually leave them a little bit high. I think that was 0.27 rather than 2.5, just to keep it so that it's on top of the job. We're not going to do the VCO. It is quite a setup procedure, and there's no reason to suspect that it's being messed with. It's locking on all the channels properly, so we'll leave it at that. So we'll start with this coil. Just make sure that this is peaked. I should be showing the power meter on the inset picture, but have failed to do so. That was a bit stiff, so I just put the soldering iron to it, but it was still a bit stiff. I didn't go any further. I didn't make it move. It's clearly in just about the right position, if not spot on the right position, because all the others were. Now we do have the ones with do have the wax in. So at this point we're at about 1.7 watts, and then it started rapidly coming up. So by this point we're now hovering around the 3 watt position. Because we're a bit interactive, we just go backwards and forwards on the others. Actually showing the right meter now. So that's on the 3 watt scale, so we're well beyond the 3 watts. It's about 3.1. So remember, it's a 3.5 watt set. The one I'm pointing to just off the picture, don't adjust that one. That's done with the spectrum analyzer. That's one of the traps for spurious. Harmonic traps, better way to put it. So in low power, it's still 260 milliwatts, which isn't adjustable. So theoretically, it should be 400 milliwatts, but like a lot of sets, it's preset. And in actual fact, I mean, we've already done the on-the-air test, and it worked all right. So looking at the meter, it should be between the two red points. So I'm just going to adjust the power meter, which is preset at the back there, the back left. Really didn't need much of an adjustment, but there we go. At this point, this transmitter was still hot. So, as you know, the power output drops a little bit when they're hot. So, I put it down as 3 watts, but in actual fact, when the radio had cooled down, it was probably 3.2. So, I did correct that to 3.1. Mind you, it's probably 5 watts on the Zetagi meter. You know how generous they are. And that brought the deviation from 15 kHz to the correct 2.2, and with absolute peak of 2.5. So it looks like we're going to take the bottom off and deal with that crystal filter that shouldn't be there. They're not just a pin for pin replacement, and the impedance needs to be matched differently, and people don't do that. And so, although there obviously is an advantage having a crystal filter, the set's not supposed to have one. And the whole idea of this business is that we make radios back to how they should be as original equipment. So we're going to have to take that screening can off as well later on. I discovered there was some dry joints. Printed circuit board's been hacked about a bit as well, getting it out. I don't think they used a solder sucker. I don't know what they did, but out of the 3 pieces of print, 2 of them were hacked about. So I then had to start putting wire links in that, which doesn't help. They'd bent the wires over to reach the hacked about print. It was actually the correct type of filter. It was 10.695, not a general purpose 10.7. But I'll send it back with the radio for the customer. It's not ours. See, he might end up buying a radio or having a radio coming into him for service that has a Duff crystal filter that should have a crystal filter. And there you've got a replacement, because it is working, but it's just not right in this radio. So when we took the crystal filter out of, was it the Harrier CB the other day, which was making the radio deaf, we found taped to the inside of the lid this ceramic filter. So we're going to put this ceramic filter, which is the correct one, into this radio. And I've got a very poorly Fidelity 1000 under the bench, so we know which way round it goes when I pluck that out of thin air. Hey presto, a Fidelity 1000. You do have to go the right way round. I think it was writing away from the position I'm sat in. Make sure the pins are straight and we'll get it put in. So we're able to solder the centre pin only because the print's all mangled on the right and the left, so we end up having to put some links in. But I'm going to, as I do this voiceover to the unedited version, we will be editing some of the pointless things out. So at this point we're going to just check for continuity with this print being damaged. I've put the links in as best I can see, so we're just making sure that they are actually making contact. I don't think one of them it was. Now these radios are not prone to dry joints, but there were some on receive on this when I actually started looking into the receiver. And it's frustrating because when you've just changed the filter, you think, have I done something wrong with the filter, or has it stopped receiving for another reason? Of course it was another reason, it was a dry joint or two. And it goes without saying they're always going to be under one of those screen plates, and it was. I had to take the one with the carpet tape on. Yes, that's factory fitted carpet tape. Just soldering two little fine strands of wire in there. Put the lid on as a temporary yeah, just temporary, because you can have this capacitive effect. I learnt this with business radios back in the Pi days. They did special jigs which were half a case, specially machined so you could put half a case on and tune the thing properly, because if you didn't, it would not be right when you put the case on. And because you couldn't do the tuning with the case on, so you had these special cases with holes in them to do the tuning. So I'm thinking, is it a dry joint? Is it the filter? So it's a matter of looking for these dry joints. Sometimes we use a vibrator. I wouldn't normally show that on video. It's a shame, you know, you haven't got the sound here because you've got the tone from the signal generator coming through intermittently as you hit the various bits. Anyway, I go through the various dry joints, having taken that screen plate off, and of course that's a swine to put back on. So we now get onto the tuning of the receiver when I can actually find the right camera. So we'll start with the detector. It's an unusual arrangement. That capacitor, the big one there in the corner, was dry joints, actually broken away from the printed circuit board. There we go, that's the detector, and it was quite a bit out. It's quite an unusual arrangement, and they are difficult to set. The two coils to the right hand side of the screening can, the big can which I've taken the lid off, are supposed to be done with a sweep generator, and I've shown that technique before, and that's still there in the back catalogue. But using the cyanide meter saves me a lot of time. You have to appreciate these were made at a time when cyanide meters, although they were available, they weren't popular in workshops. And I remember we bought a second-hand one for about £800 when I was at Nottingham Radio, so they weren't a cheap thing, and they're still not a cheap thing. I don't know why I'm not showing the cyanide meter at this point though. Perhaps I'm rough tuning it. Okay, so we've got this situation here where that capacitor in the corner is quite clearly a problem. So when I take the lid off yet again, I actually find that for some reason it's actually broken away from the print in a perfect circle. So you can't actually see that it's broken away. So I unsolder it and realise there is no print there. That was kind of predictable. Just remove some of the solder screen. That's the green stuff. And then that gives me a wider area to resolder that capacitor. As I was tuning it, I thought it was a bit hissy. And then touching that capacitor, it was intermittently better. So yeah, that's now soldered to those wider pads that I've created. I don't show the 15 minutes of me putting the screen plate back on. We're now looking where the meter is. I'm just looking up on the manual which the preset is. It's the forward one of those two, isn't it? But we can't kind of quite get it where we want it, because we want it to be 100 microvolts for S9. In actual fact, it turns out we can't get it nearer than 95 microvolts. So it's a little bit generous. So this is where we're working out how many microvolts it is. So that's got the sensitivity, oh, I can't even speak. That's got the sensitivity back on the squelch. Because that 1.9 might have been a bit choppy around scratchy corner, but 0.68 is fine. And really all that I've had to do to correct that is to get rid of that crystal filter. Notice I'm just changing it to 3.1 watt. And it's absolutely 3.1 throughout the 40 channels, which is surprising. This is the point where we get the S meter reading. Time to solder that lid back on. It's just to stop microphony, so the kind of radio innards don't electrically rattle. Right, we'll finally get to see the cyanide meter. We're going to start with 12, we are. 0.38 microvolts, how about that? Zero 0.3 for 10 dB. 1.1 microvolt for 20 dB, so it's really sensitive. And this is their undoing. They're oversensitive, and without the good filtering circuitry, they are bleed over boxes, but they're not if you're in a rural area like I am. They work okay, and they work okay in the car, but not to be used as a base station in the middle of Nottingham city centre. The next and final part of the video has original sound. Right, so you don't need to see me screw that back together, and we'll go over to the final part of the video where we plug the aerial in and we just have a flick round. Right, so here we are on the aerial. One nano, Roger. No, Roger. Well, there are some voices from about 40 miles away there. Right, well, there we have it, the Fidelity 1000. The on-the-air test will follow, and you'll be surprised how well these will work in a rural location like this. So I hope you enjoyed that, and I really didn't expect to have to take a filter out of it and to have the dry joints and that, and I genuinely thought, like the customer did, that was a Roger bleep. Thanks for watching.